My clock is 10 o'clock. My watch is 10 o'clock, so we'll start now. And I hope you like the crowded seating. It's because you're supposed to talk to each other when nobody's talking up here, and it's easier if you sit like this, even though it's very crowded. So, very welcome here to this seminar, Shipping in the Marine Environment. And my name is Åsa Burman, and I will be the moderator of this day, this seminar. And I'm the former director of Lighthouse. Lighthouse, the Swedish collaboration platform for maritime research and innovation. I have a successor in Andreas Back, who is standing there. And I am now acting as a senior advisor. Everybody has to be a senior advisor, I think, sometime in their life. And now it's my turn. There are no evacuation tests today, so if there is an alarm, we go out to this round building, Kuggen, and well, that's about it. And you've seen the toilets out there, and we will get coffee, food, and whatever, and a lot of time, I hope, to mingle with each other. Lighthouse we have arranged many seminars during the years. I've been working here for 11 years now, and we have had many seminars about many different things. And we have had AI, we have had about fuels, a lot about alternative fuels, about electrification. Now it's time for a seminar that is about what is happening in the water, in the ocean. How does shipping impact the marine environment? But we will not include underwater noise, because we think that is a very huge topic, so we will have a separate seminar about that this spring. Isn't that so, Andreas? What can he say? We've had help to arrange this seminar from both Chalmers and IVL. Thank you very much. And the program today has, as you see here, quite a few speakers. And all of them have been told that they have 15 minutes to present and 5 minutes for questions. So I hope this will work. The first two ones only have 10, and they don't get any questions. We will have an overview first. Then we will have a theme, policy and financing. Then we will have quite a few research presentations. And we will end up with industry, a tanker, shipping company, and a port. We'll talk about how they address the environmental impact from their operations. So, with this, I would like to start with the overview. And from a research perspective, I'd like to introduce Ida-Maja Hasselöv, who is professor in maritime environmental science at Chalmers, where she's also leading the thematic area Ocean, connecting marine and maritime research across the university. Also active in the shipping group in the Swedish Institute for Marine Environment, Havsmiljöinstitutet, and coordinating author of the shipping chapter in the upcoming 3rd UN World Ocean Assessment. Welcome, Ida-Maja. And you get this one.
Oh. That one. Thank you. Fantastic to see all of you here. It was very loud. And something is shouting. Yeah. Good to see all of you here. I got the honor to introduce us to the topic of today, which I am very happy about. And as you heard, that Åsa stated, 11 years. You can imagine that we have been asking about this before. But finally, we think it's great that you have this as your final event, Åsa. But I would like to start with putting the shipping environmental impacts in a little bit wider context. And then I borrow this this figure from Joffrey et al. At Stockholm Resilience Center. So it's the overall so-called blue acceleration. So the pressures that the human activities pose on the marine environment, not only shipping, but shipping is among them. But just to understand that it's important to realize that shipping is one type of pressure on an ocean that is under a lot of pressure right now. And another way of picturing that is to look into the economic perspective. And I think that many of you have heard for long the forecasts that the blue economy is outcompeting the economic growth, the overall economic growth at global level. And also within the European Union, that is the case. But here, it's important also to understand that there is a need for better KPIs to actually be able to follow what the value of the blue economy is. And these figures, as you can see below, we have maritime transport, which is the most linked to what we are discussing here today, but also the shipbuilding and repair and port activities are closely related. And as we can see, there are large figures, and this we need to keep in mind also when discussing what the degradation of the marine environment implies in economic terms. In order to study pressures from shipping or other sectors, it's a need to structure cause-effect relationships. And one such conceptual model that we often use is the so-called DAPSIR model, where we start with drivers. So, for example, the need for transport that give rise to different activities, such as shipping, with a lot of onboard systems. And these onboard systems, in turn, give rise to different pressures on the marine environment that will alter the environmental state. So the state will change in the marine environment. And these changes, in turn, may have an impact for us as humanity and the uses we have of the marine environment. And if we find that that is not an acceptable impact, we can undertake different measures, have a response. Then it's possible to iterate this circle again. I know that many people in here must be pretty tired on this figure, but I also know that there are some new faces, so I will ask the ones who know it from before to bear with me. But just to provide a quick overview of the different types of pressures, and we will hear more about them during today's research presentation, so I will not go into any deep detail. But if we start here left, even at anchorage, ships do pose pressure on the marine environment, both in terms of scouring the seafloor, but also noise pollution when deploying and retrieving the anchor. And also, many of the onboard systems are up and running during anchorage. But then, when the ship starts to move, we have the risk of collision with marine megafauna. Smaller fauna are fouling on the ship hull and give rise to increased friction when the ship is moving through the water. To try to combat that, most ships are painted with toxic antifouling paints. Ballast water is also a risk of spreading non-indigenous species to new areas. We have sewage or black water and greywater from laundry and kitchen areas and showers and sinks that may contain nutrients and cleaning agents. Cooling water can be residuals of virtually anything that is being transported. However, in the Baltic Sea, for example, you are not allowed to discharge tank cleaning residues from mineral oil products. Cooling water, just like preventing growth on the ship hull, it's important to prevent growth within the cooling system. So copper and zinc are usually used here to prevent that. We have the scrubber water that we will hear more from both Fredrik and Karin, I guess. Today is exhaust gas treatment, and Mia as well will talk about the effects of scrubber water. an exhaust gas treatment system. So it's actually this arrow that is instead being directed directly to the marine environment. We have the bilge water, so basically condensed water and oily residues and cleaning agents in the machinery spaces. We have the engine operation that give rise to underwater noise and also the propeller cavitation. Another type of energy pollution is waves and turbulence. Waves are pretty well studied, but turbulence is an emerging area. Most ships have a propeller shaft that is lubricated with mineral oils and that will leak over time into the marine environment. And then we have the atmospheric deposition of sulfur and nitrogen oxides, for example, and particulate matter, and also solid waste, primarily ground food waste. Finally, we do have illumination, so artificial light at night, which is also a new type of energy pollution that is receiving increasing interest. Most of these, onboard systems are regulated in some way. So for example, ballast water, we have the Ballast Water Management Convention, and we have the large MARPOL regulatory framework at global level. But as you can see, some of them are also blank here. But that is from the shipping perspective. So from the shipping perspective, each of these onboard systems are regulated one at a time, one ship at a time. But from a marine environment perspective, then it's important to consider all the sources that contributes to different type of pressures. So for example, contaminants we can see is coming both from the antifouling paints, the ballast water, sewage, etc., the scrubber water. And I should mention also that the arrows here are not proportional, so just to keep that in mind. And today, the state of knowledge today, we know that shipping poses substantial pressure on the marine environment. And for example, polycyclic aromatic hydrocarbons and metals to the Baltic Sea, scrubbers and antifouling paints are recognized as important sources. And still, while we know that this is the Ocean State Report that was released a few days ago, and I was very happy to see that under human pressure chapter, they had actually listed shipping first. And then I was extremely disappointed because the only thing that they mention is with respect to the CO2 emissions. And that we must change that. We need to raise the awareness to include other pressures. Finally, Åsa, wrapping up the ongoing research. We will hear today about scrubber water, ballast water, biofouling and antifouling, greywater, and tank cleaning. And finally, Roland will give a presentation that integrates over several of the sources. But as Åsa also mentioned earlier, we do have active Swedish research, for example, related to underwater noise and new projects on turbulence. And in addition, I should mention that emerging areas, internationally there is more interest regarding the illumination and also container losses and anchorage and ship strikes with collisions with the marine megafauna. So we will not be able to cover everything today. Therefore, we are planning a large conference next year in September. I hope to see many of you there. More information will soon come, so stay tuned. Thanks a lot.
Thank you. Thank you very much, Ida-Maja, for that introduction. From the research perspective, we had an overview, and now we will get an overview from the regulatory, from a governmental perspective, from Fredrik Lindgren, Swedish Agency for Marine and Water Management, Havs- och vattenmyndigheten. And you have been working there since 2018, and prior to that you actually were a PhD student at Chalmers, originally a marine biologist, and you work with marine environment action programs aimed to reduce environmental impact from shipping and recreational boating, including hazardous wrecks, environmentally hazardous wrecks. And please, Fredrik.
Yes, thank you, and thanks for having me today. So I actually work as a senior advisor at the agency.
So young.
So I will try today to give just a short introduction. What is SWAM, Havs- och vattenmyndigheten, and then I will dedicate most of my talk to trying to explain the Marine Strategy Framework Directive, which is actually why I am here, or why SWAM are working with this environmental effects from the shipping industry. And then I will give two brief examples of how we are involved in various processes. So SWAM, Havs- och vattenmyndigheten, is the responsible governmental agency tasked to protect, restore and ensure sustainable use of freshwater resources and seas, including fisheries management. We have a general director, a new one since 1 year ago approximately, Anna Ledin, and we are more or less 300 employees with a main office here in Gothenburg. But we also have other offices in Simrishamn and Karlskrona where they do fisheries control. Okay, so the EU Marine Strategy Framework Directive. So this is the cornerstone for the work of marine management. It covers the marine waters from the coastline and all the way out to the economic zone. So, and the aim here, as you probably heard many times before, the aim is to achieve good environmental status in the EU marine waters. And this is performed in 6-year cycles, like you can see in the picture to the top right. So when you have defined the ideal environmental state of the seas, and then you set targets how to follow up on this, then you monitor the state of the marine environment, and when you have assessed if you achieve good environmental status or not, and if you don't reach good environmental status, you need to identify and implement actions. And then you do this all over once again in 6-year-old cycles. The plan is to until you have reached good environmental status. And this affects all member states that have a coastline. They need to do this. And you do this by looking at or working with 11 different descriptors how to assess or work with the marine environment. And why I talk so much about this today is that the MSFD is implemented in Sweden through the environmental code, the miljöbalken, and through marine environmental regulation, the havsmiljöförordningen, and also föreskrifter or regulation or measures from SWAM. So we are the responsible governmental agency for this. We implement all parts of the directive, and we also have the right to adopt measures. So therefore we have a program of measures that other authorities need to take responsibility in order for Sweden to fulfill all its obligation under the directive. So if we don't achieve good environmental status, we need to identify and implement actions. So we have a program of measures that has now been in effect since 2022, and there was also a program of measures before that, and it reached until 2027. And it's directed towards other governmental agency, but also towards SWAM, the different measures, but it also can be directed to municipalities. And it can be directed to the whole marine environmental area in Sweden, but also or towards one or another sea area. So for example, also only to the Swedish west coast or to the Baltic Sea. Okay, so Like Ida-Maja said as well in her talk, that shipping has been identified as one of the pressures that affect the marine environment negative. So we have in the program of measures, there are about 45 measures, I think. So, but as shipping has been identified, and we know that within our territorial waters, within our economic zone, we have a lot of shipping. So therefore, we have a measure directed towards to minimize the environmental effects from shipping, which is called OPH 38. And here we have 4 subcategories that directed towards limiting or minimizing the environmental effect from scrubbers, from PFAS in firefighting foams, tank washings from Annex 2, shipping, so to speak, and also from stern leakage from stern tubes. So within the area of scrubbers, we have been very active in the latter years. We have had 2 governmental remits together with the Swedish Transport Agency. We have produced scientific-based documentation together with the universities and others regarding scrubbers, for example, regarding tank washings, but also concerning greywater, underwater radiated noise, firefighting foams, and in-water cleaning. And this material is then used nationally, for example, in these reports for governmental remits, but also in the international work, together with the Transport Agency, within IMO, within HELCOM, and within OSPAR. And one other example I just wanted to mention is that where we have been active is the tank washings from ships offloading chemical products, where they need to, very commonly at least, clean the tank before loading a new cargo. And as you probably know, there are some prerequisites that need to be fulfilled before you're allowed to release these tank washings into the sea. But there can also be illegal discharges. So we have also been looking into this area together with the university, but also together with HMI. We have had dialogue and workshops with the national industry and other authorities, together with, once again, the Transport Agency and the Swedish Coast Guard, how to minimize these effects. We have also produced scientific-based documentations looking at the effects in the marine environment from these tank washings, and looking at analysis of AIS pattern. We will hear more about this today. And also using this in the international work, IMO and HELCOM. And my last slide. This program of measures, it's active until 2027. After that, there will be a new program that will run from 28 to 2033. We are now in the progress of updating this, as you can see here in the picture to the right. We will probably continue to have the 4 subcategories within OPH 38 with some readjustments in text. But we are now looking into new measures concerning shipping. Should we introduce measures connected to underwater radiated noise, antifouling paints, greywater, and sensitive or protected areas? See if shipping can be moved or directed or informed about these areas. So now we are having dialogue with all the involved stakeholders, authorities, industry, and academia, because these new proposals are now in a commenting phase, and it will continue until it's decided in the December 27. So there is still time to go. You will have the chance to have comments in this. Okay, thank you.
Thank you. And as I said earlier, if you have questions to Fredrik or Ida-Maja, you can post them in any of the breaks. But now we will move to the first theme of the day, and that is policy and financing. And we will start with a presentation from the Swedish Transport Agency with the title Marine Environmental Regulations, Current Rules and What's Coming Next. And we have two speakers, Karin Almlöv and Erland Lettevall. Karin has a sea captain's degree with experiences from the merchant fleet, both from working on board and ashore. And she has been working with the environmental impacts of shipping since 2016 and is currently, as most of us seem to be, a senior advisor at the Sustainable Development Unit of the Swedish Transport Agency. Erland Lettevall, however, he is a senior environmental specialist at the same department and has a PhD marine zoology from the University of Gothenburg, and he has been working on biodiversity in aquatic environments with a particular focus on managing invasive alien species and underwater noise. And he's also dropping things. The floor is yours, Karin and Erland.
Thank you. Thank you for having us. And hello to everyone. Here we are. Yeah. Oh, I have this one as well. Nice. Yeah, thank you for having us. Our work at the Swedish Transport Agency is guided by political goals for sustainable transports. And today, in this presentation, we will give you a brief overview of current regulations, what's going on at the Swedish Transport Agency, and what's coming with inspiration of today's agenda. And we will start with the scrubbers. We will have here presentations later today on scrubbers, so I don't have any time to go in to the phenomenon, but I go directly to the regulations. And in 2023, the International Council on Clean Transportation presented a study showing that 45 countries had some kind of restrictions or bans on discharges from scrubbers in different ways. So that was encouraging. And here at home, since July 2025, we have a discharge ban from open loop mode in Swedish, Danish, and Finnish waters, and for any mode in 2029. And this maybe sounds pretty good, but actually what it means is that you can still run your open loop scrubber or you scrubber in open loop mode all the way to the territorial border, and then you can continue discharge your discharges from the closed loop systems in our archipelagos and ports and so on until 2029. So what do we do at the Swedish Transport Agency with this topic? Sweden has the lead of one of the actions in the Baltic Sea Action Plan, and the action is called S22. And I put the task in text here, as you see, and the task is to develop a roadmap by this year to deal with these discharges. And me and my colleague Helene Johansson, also at the Swedish Transport Agency, we have been leading a correspondence group with all the HELCOM countries, the EU Commission and observers to HELCOM, to manage to get a roadmap that we can all agree on. And we will know in 3 weeks' time in Riga. But we have set our goals very high for this roadmap. We also are involved and very active in international work at the group called Scrubber Water Action Group. We meet at the IMO, and there's countries from all over the world participating in this group. And Sweden would co-host a side event at one of the IMO meetings in January next year on the legal aspects of the uses of scrubbers. what's coming. Yeah. And once again, I had to put the text here about the OSPAR decision. OSPAR, as you all know, is the Northeast Atlantic area, in short, and they've taken a decision on open loop scrubbers at 2027 in internal waters and ports. But in the HALCOM area, we want, as you maybe could guess, be a lot more ambitious. So our roadmap that I told you about, it's focusing on first goal to get a harmonized approach in territorial seas in the Baltic Sea area, or the ultimate goal that we're aiming at is this total discharge ban in the Baltic Sea. And this is a process that needs to go through the IMO. And we think our best chances in succeeding in this task is to go with the area that is a PSSA, that's been designated by IMO as a PSSA, particularly sensitive sea area. So that's what we're working on and aiming on. So wish us luck. Thank you.
Handing over to me. Thank you, Karin, for that start. And again, really appreciate to be here from the Swedish Transport Agency. And I will continue to talk about the regulation on ballast water management and invasive aquatic species. And as you know, and it will come later today, we will have more information about the ballast water management related to Ballast Water Management Convention and the biofouling management, like hull cleaning. But also is the convention on antifouling. But I will not continue to talk about that. I will continue to talk about the update of the Ballast Water Management Convention, and also that we are developing mandatory requirements that may be a new convention or new regulation. Let's see. So I continue then with the update of the Ballast Water Management Convention, and we are in experience building phase. That actually means that the convention has been implemented, but and the rules are sharp, but we are updating to make it more relevant and learning from experience. So some of the changes and updates are not done yet. So that experience phase building is continuing from 2023 to 2026. So the ballast water management are probably a new version coming year. And the amendments are ongoing right now. We are quite many objectives that we have to change and improve, and also including some new changes. And we also have amendments about the ballast water management system code, and we also have some guidelines and guidelines that are updated, and also new guidelines. And these guidelines are not binding guidelines. The Swedish Transport Agency then representing Sweden in the correspondence group at the meeting to develop the draft to change the convention. And then of course we have to take it back and implement it in national regulations and guidance. So upcoming next year we go through a package of approvals and amendments, and hopefully in autumn these amendments and provisions will be suggested to other amendments in the regulation or new instruments within IMO. Then I continue with the aquatic species that we are developing mandatory requirements for biofouling management. There are already both guidelines and guidance, but it has been, during the time it's been developing, many states and the international community are asking for some mandatory requirements, so it should be similar independent on where the ship are going. So there is a plan how to make this very transparent and how to develop a suggestion for mandatory rules that may be then regulations. And I can explain how that will go. We haven't decided yet exactly what kind of regulation it will be, but there is 2 phases of a biennial work, so that there are lots of recommendations that will be suggested in a draft and may be suggested as a regular binding framework. And in the next biennium for this work, for additional 2 years, we will work until 2029 to finalize this regulation. And many may ask, may this take long time or short time? It's a very positive plan for 4 years. It's built on experience for Marine Pole Annex for 6, that was 8 years, the antifouling system for ship convention 7 years, and the ballast water management convention for 13 years, and so on. So it's probably a quite positive timeline, but this is what we start, and Sweden is supporting this timeline. And what's important then for that, it's during the negotiation for the management of antifouling, for biofouling, is that Swedish find a line in the discussion with the different stakeholders in Sweden, both authorities and the shipping industry. But in addition, I also would like to mention that is a regional guidance for OSPAR HELCOM, that the North Sea and the Baltic Sea, and that is in specific something that will overlap the international guidelines, specific adapted for regional conditions. So that work is also ongoing, and probably it will this guidance will be ready next year and support the different member states how in specific biofouling management should be carried out in our sensitive areas. And we're also working as the SWAM was presenting, and with a Marine Strategy Framework Directive on a specific action on biofouling that we will develop for the national situation. Guidance, but probably also develop the regulation we have for hull cleaning, the release of chemicals and biological organisms in the water when you're cleaning the hull. And we also, I change field now from aquatic invasive species to greywater. We're working with greywater regulation, and there is currently no prohibition for discharging greywater from ships in Swedish water, but there is a discharge ban in Finland, in Finnish territorial waters, from 2030. And we're looking carefully on this, and we're also inspiring science on this, and I know there is a commitment to Chalmers to give us more information how we should then develop a national direction in that area. And it also is a part that we have to work with an action within HELCOM and OSPAR, and there is an action in HELCOM that Sweden has to work with, and that will also be a complement to MARPOL Annex 4 at the IMO. So, Karin, I hand over to you for finishing our regulation talk.
Yeah, and we will jump to tank cleaning. And this is tank cleaning from chemical tankers and chemical cargoes, as Fredrik earlier started us up with. The way to new regulations to involve more cargoes for pre-wash, for example, is very, very long and a complex way. But we haven't given up. In this year, in 1 month's time, we will co-sponsor a submission to IMO to have some more cargoes on this list. But I think we will have chemicals tankers for many, many years, and we need to try some different things here, and to have a common responsibility to save our seas from this kind of loads. So the Swedish Transport Agency, we are now looking to information campaigns and to start them up with the shipping companies, cargo owners, ports, and so on. And we think that the solution is to deliver more things to port, but it's a complex system. But we are working on it, and we need your help. So thank you. Any questions?
Thank you very much, and now you're allowed to ask questions, and I can start by asking one. Do you think they will meet those dates that you have set up? Will Sweden align, and will those days that you have set up, do you think they will be met, or will they be...
For the biofouling management requirements, yeah. It depends also on how prepared the different member states and the international community are to implement it. So if everyone are very prepared and ready for it and trained for it from previous regulation, then it could work. But I think we should add some years for that, for these 4 years.
Okay. Name and where you come from, please.
Hello. So it says that it's on, but it's...
Hello, hello. Hello.
This one may work. And I can tell you his name is Sven Borén, and he comes from Blekinge Tekniska Högskola.
Yes, thanks for that introduction. I heard that there is an ambition from STA about the scrubbers, but what ambitions do you have when it comes to ballast water management and biofouling regulations in that work with IMO? Do you have any specific ambition or target that you are trying to instigate on IMO, or?
Now you mean specific biofouling management, and yeah, we haven't set up really the goals yet, and that is a line that we are looking for. It should be science-based, and it should be transparent. It should be practical, manageable. But we are very aware about the longshore and many sensitive areas of high biological value. So, but we also have important shipping industry. So we haven't really set up the goals, but we are supporting the management guidance that we are developing. And we're looking in specific which parts of that is good to make on a international legal base, and also with support of the HELCOM OSPAR discussions we have, that we also look at. I mean, but this is specific for our area, so that should not be put in a international regulation. So that is how we are thinking, but I cannot say clearly now this and this and this and that is our line.
Okay, thanks.
Thank you.
Claes Berglund from Stena. No, there was another one. Björn Forsman from RISE.
Okay, thank you. A question to Karin about scrubber washing water discharges. Did I understand you right that for hybrid scrubbers it will become prohibited to discharge within the territorial zone, but not in the outside? Does it mean that you can collect, if you have a hybrid scrubber, you can collect your washing water while you're steaming a couple of hours inside the territorial water and then discharge it when you leave the territorial waters?
Thank you for your question. That would be the case after 2029, yes, if we don't succeed in our things at the IMO. Yeah, so sadly that would be the case, yes.
But the new regulations mean that you can't use open loop scrubber within territorial waters, right?
Exactly. Since the 1st of July this year, you cannot use the open loop scrubber in territorial seas. Yes.
But you may use closed loop,
Yes.
and then you can collect washing water on board, and then discharge it when you leave the territorial water in the economic zone.
Yes.
Yeah. So that means that in practical, you move the pollutants a bit further outside the territorial and discharge it in a more concentrated way, perhaps.
Exactly.
Okay.
Yeah.
Thank you.
Thank you.
Claes Berglund, Stena.
Thank you. So first of all, thank you for organizing this conference. I obviously represent the shipping side of this, and we are very grateful for all the research that's ongoing. And as we learn more and more about how shipping is impacting the environment, we try to adopt the new regulations are coming, which we of course welcome as science develop. We were strongly recommended to put on scrubbers on our vessels about 10 years ago in Brussels, and now it's the other way around. So sometimes it's tricky to follow all this. But my question is really, we're talking about all these different pollutants or pressure, which Idama explained very good, I think, on the ocean that shipping is causing. Wouldn't it not be better to regulate the emissions themselves instead of the source of the emissions? For example, scrubbers. I mean, I think it's fantastic if the regulation that's coming now with that we cannot have the scrubbers. But for example, what happens if we can dispose the water on land and get it clean there? Is it still a ban on scrubbers then, for example? So my view is that we should probably regulate the emissions rather than the source where it's coming from. And I would like to hear your view on that. Thank you.
Thank you for your question. But you are absolutely right. We are regulating not the use, the discharges. So these regulations and everything that's upcoming, everything that's in the pipe right now, is to focus on the discharges and the pollutions. It is not targeting the technology or the use of scrubbers. So it's there are the discharges to see. That's everything that's in the pipe. If they are clean, the discharges are clean.
We're streaming, so you need to use the microphone.
In a case, if I understand you correct, in a case where we would have absolutely super clean, like drinking quality waters coming out from the scrubbers, why not? But that's not the case right now. And we will hear more about the scrubbers and what the discharges contains later on today. So, no.
Could Idemeier, you will borrow mine.
Okay, just a comment upon that. I agree what Karin said, that is actually the case, what is being regulated. But this discussion on how clean the scrubber water should be before being allowed to discharge, that puts a lot of constraints in terms of analytical measurements of controlling that the scrubber is compliant, and that is actually a technical challenge, an analytical, chemical and technical challenge in the first place. And then in general, I must say that what Claes mentioned, Swedish ship owners are in general very ambitious and want to do the right thing, not only be compliant, but as we see, we have many examples where the Swedish ship owners are moving beyond compliance, and therefore it should be a competitive advantage if we can work together there. But comparing with all the different pressures from different sources, one must also bear in mind that shipping is one type of source that is actually possible to regulate. Even if we see that we have diffuse runoff from land, for example, that is extremely difficult to both put measures on and to regulate. Thank you.
I think we have time for only one more question. Or
Okay, thanks. Niels Krabbe, I'm with the Department of Law here with the University of Gothenburg in Sweden. I really do appreciate the confusion from my colleague here from Stena. And just to be clear, what we're talking about here is Swedish domestic law, right? So under international law, emission of scrubber wash water has been prohibited and remains to be prohibited. And much of the confusion is due to developments with the IMO the past 20 years or so, where they've tried to get around emission problems by enabling technology and guidelines, which basically, guides and provides recommendations for ship owners to instead emit those pollutants into seawater, which is in violation with the Law of the Sea Convention. So much of this work is about trying to make and turn domestic legislation to be in line with international legal commitments, which they currently aren't. And this is much due to a pretty remarkable developments with the IMO in the past 20 years or so. Thanks.
Okay. Are we happy with that last question? And you have to, but we actually are a little over time. Just one more then. Very short, very short.
Thank you. I just wanted to say that the...
Who are you and where do you come from?
My name is Maria Granberg and I'm from IVL, Swedish Environmental Research Institute. Hello, everyone. I just want to say that when we talk about scrubbers, it's not an isolated issue. The ships that use scrubbers are carrying heavy fuel oil. I work with oil pollution, and I have been working a lot in Blekinge, where there was a big spill with a scrubber, a ship having a scrubber with heavy fuel oil leaking out and affecting the ecosystems there. So these issues are linked. And the idea with the regulation from the beginning was to change the fuel that we're using. But by introducing the scrubber possibility, because the other oil is much more expensive to use than the heavy fuel oil, we keep on using the heavy fuel oil, which is very bad for the environment. I just want to add this because we're talking about scrubbers as an isolated issue, and it's not, it's a system.
Thank you, and you will talk about scrubbers in 1 hour or so. So, and no more questions now. We have to continue. Actually, so thank you very much.
Thank you.
We should have put half an hour more on that one. And now we're changing, we said policy and finance. And the next presentation is from the financial perspective with the title Finance in Maritime, is Sustainability an Issue? And the speaker is Arne Joel Skilse, CEO of Svenska Skeppshypotek.
Yeah.
But it's not only CEO of Svenska Skeppshypotek. He's a master mariner, has been working on board tankers a couple of years.
Yeah.
As second and chief officer. And then you added some studies and ended up working in a bank for 20 plus years. And now you're the CEO of Svenska Skeppshypotek since 2021.
Yeah,
Welcome.
That's right. Thank you very much for having me here. So all of the emissions you've shown here on the slides I've been part of directly. But the positive thing is that since I was at sea, things have actually gone better, although there are a lot more ships today. So even the slightest outlets today are, we need to work on. Anyhow, shipping finance, what's that? Well, someone has to pay for the ship. I think there's an automatic thing. I didn't do anything. Anyway, let's see if it works. Oh, I see. Anyhow, shipping finance, how do we combine regulators, science, and the corporate world? And where does it come in? So I'm going to talk about, you're probably not going to see exactly what I'm trying to aim at, but bear with me. It's sort of a red thread throughout this. So although I work for it changes. Although I work for a specific financial institution, I tried to do this a little bit more generic from a banking perspective. The institution that I work for is actually a state-run institution. The only thing we do is to finance ships and ship owners related to Sweden. We actually have our own law. So if you Google on the law, Svenska Skeppshypotek, you can actually read what we can do. We actually don't have a formal owner, funnily enough. The only one that can change us would be the parliament. And I guess that's why we're still here. We're nearly 100 years old. In essence, what we do is to borrow money from banks cheaper than what we lend it to the ship owners. And that spread between is our profit. That's how we make our money. We never actually got any money from the state, and we haven't made a loss since 1940. So it's actually working quite well. When it comes to sustainability for a financial institution, I think we all want to be green. That's all sorted out. And how do we get there? Well, that's where regulation, science, and the corporate world meets. It's difficult to sell sustainability for a bank. But on the other hand, if we look at the institution itself, what is sustainability for the institution itself? Well, we need to have a good economic standing. We need to have a product that there's demand for. And also, we need to have an established market presence. That's sort of the basics for us to survive long term, right? In addition to that, in order not to fall into any pitfalls of not looking after the social responsibility, the environmental questions, etc., we need to be delivering on that as well, because otherwise, we're not responsible towards our stakeholders. And the stakeholders for us would be very much the ones who lend us money. So we borrow from the banks. If they see that we're not good enough, they won't lend us money. So that's sustainability for us. That would be a financial standing and products that there is a demand for, and we also need to behave. So how do we get there? Well, we get there through our clients, right? So we get there through our clients. And if we have clients that doesn't behave, they're in the newspapers, dispersing oil, etc., it doesn't work for us. What do we look for in clients? Well, they got to have a financial standing themselves. They need to be good at operating their ships. And they need to have a long-term competitiveness. And this is where sustainability comes in. The most important thing for us is to understand that what we finance will survive long-term. We are a very long-term player. We finance ships until they basically retire. If they can't be long-term competitive, we'll get into the picture on the next page. So this is where we can make our choice. Can we alter, Claes here at Stena, can we alter you when you want to order a very conventional large tanker? That's difficult. We are one amongst many financiers, but we can also opt to, not do it. That's sort of what we can do. We can always discuss and say what we think, but usually a banker is a pretty lousy technician, so we don't necessarily have so much to say in those respects. But we can always say, look, it's not good enough for us. We won't do it. So we have sustainability for us as an institution. The sustainability for us comes through our clients. And at the end of the day, we obviously don't want to end up with stranded assets. That's what it's all about for us. We make this into a credit issue. We think that by financing this shipping company, they have a strategy in place for the transition to zero carbon shipping over time. They have a good understanding of the regulatory framework, and they also have a forward-leaning attitude towards change. That's what we're looking for, because a bank that ends up with a client that has very little economic strength left, they have ships that are extremely expensive to operate, we're going to end up with those ships in our lap. And bankers are terrible ship owners. So we always look for a transition strategy in our clients, and also that the ships are fit for sort of making the change over 20 years. That's what we look for. I think specifically, we talk a lot about scrubbers. We don't finance scrubbers. That's sort of the only specific thing, I think, that we have made a decision on. That, scrubbers, well, they probably filled the function when they were approved to use, but not anymore. It's time to get them away. So we said we don't finance those. That's sort of the only explicit thing that we said no to. When do we say no to a ship owner in general? Well, that is when we feel they don't have the edge and understanding how they should develop in a positive manner. It is a very difficult thing, this to choose who should you finance. And as such, sustainability itself doesn't repay your loan. But if you're not sustainable, you will not be able to repay your loan. So we make it into a credit issue, and for us, this is it. We don't want to end up here. I think that's sort of it. So for us, sustainability is an economic standing ourselves, and that we have a product that works, and that we're also seen as a sort of a good partner in society. And then we get sustainable through our clients that behave in a good manner and have good quality assets and possibility to repay our loans. That's how we look at sustainability, and it becomes actually a specific credit issue. You need to be able to repay your loans, and if you're not able to change into other types of fuel, you're not following the rules and regulations, you have to buy your emission credits, etc., etc. I think you're not going to end up as a client with us. That's how we deal with it.
Thank you.
Yeah.
Thank you. So, do you have any examples of, not the name of a company, but what kind of ship that you have said no to? Do you say no often?
No, you
or are they so good when they come?
You're around and you only sort of connect with the ones you want to deal with, right? I mean, that's how we work as human beings, I think. But we do say no, and it very much boils down to the fact that we don't think that the company as such is really in for it. They are more, well, it works today. We'll sort it out when things change. Well, it very much boils down to whether a ship is equipped for transforming. And also, we find that the sort of older traditional ship owners that doesn't necessarily think that, they need to modernize so much, they usually won't make the cut, because we do need forward-leaning people in the organizations.
Okay. Thank you. It's a question.
Hello, my name is Kent Salo from Chalmers Maritime Environmental Sciences. Actually two questions. How the fraction of the new builds in Sweden, how many of them are financed by loans from Skeppshypotek? And second one, do you have any scientific committee or something to discuss with when you make your decisions, or how do you get informed?
Yeah. Well, firstly, if you look at the Swedish flagged fleet and the vessels that have finance, we finance about half of those ships. So we are well established on the Swedish flagged ships.
but the Swedish flagged ships are not so many. When it comes to the Swedish owned fleet, we're obviously not as dominant as we are on the Swedish flag, but we do have a real market presence. The typical client of ours would be the sort of smaller tanker owners around Sweden. That would be the typical client of ours. And sorry, what was your next question?
Do you have a scientific committee? That's what it's for.
So if we have a scientific
inform
committee,
yourselves.
yes, I have the two client executives, Anna and Johan here. They deal with that, but no, sorry. We just try to stay as updated as we can. We don't have a scientific committee. As I tried to explain, we try to be rather sort of neutral on techniques, whether you will go for e-methanol or hydrogen or so forth. You know, it all boils down to economics. If you're building a ship that can only run on hydrogen today, you will probably not get finance from us unless you have a contract that sort of provides you with a hydrogen. You know, it is difficult to meet sort of science and economics. It is, but we do our best. But it is it is the front people in the office that takes that decision.
Thanks. Sven Borén, BTH. I was wondering about, okay, so if you signed up for loaning for a new ship fleet or something, and then you realize after 10 years that these guys, they don't follow the regulations that we have in this contract. How do you deal with that? Do you just simply increase the interest rate, or how?
Yeah. No, it's a good question. I think we always try to be partners, and partners always talk. So you get the feeling, before those 10 years that, wow, this isn't panning out as we thought of. Having said that, for instance, what we do is to see how many detentions or recommendations the ships that we finance get in port state control. That is a pretty good measure on, whether do you have a good, do you run your operations well? When we run across shipping companies we do, right, where they get a lot of recommendations and detentions, we ask them to come up with a explanation and a solution to the problem, so we fully understand how they will sort this out. At the end of the day, we always have a way in our agreement saying that if we believe that we're going to lose money on you, well, please pay us back. So we can always ask you to actually pay us back. You don't necessarily need to default on a contract. We've never done that. We've always worked with the clients. But it is a difficult question. It's not the black or white answer to it.
Okay, thanks.
Okay. Thank you. Are there any more questions before the coffee break?
If there aren't any, please email us if you have any questions. And we're on the other side of the river.
Yes.
We got great coffee.
Thank you, Arne.
Thank you.
And we will start again 11:35, when you will sit in here and be quiet, and we will continue. And we will have 6 different presentations in the research area. So please go out and have coffee. you for being back in here so efficiently and on time. We will now move to the research section, and we will start with a presentation called The Impact of Scrubber Water on Marine Organisms. And the speakers are Maria Granberg and Xiaoju Chen from IVL, Swedish Environmental Institute, and Maria, known as Mia. Yes, she's a marine ecologist specialized in ecotoxicology. She works in the temperate and Arctic regions around topics related to impacts of oil spill, as well as plastic pollution on marine life and ecosystems. And Xiaoju Chen, also called Carrie, much easier, is a marine biologist with aquaculture background. She works in the temperate and tropical regions on topics related to effects of pollution on marine life and ecosystems. Welcome up, and let's hope this works. So, and I hope this one works as well. Yes.
Thank you. Hi everyone, I'm Carrie, and here together with Mia, today we're going to talk about biological impacts of scrubber effluent on marine life. Here's a photo I took of seawater randomly scooped from the surface of the sea in Leisure. As you can see, it's full of life. There's 2 eggs and a zooplankton approaching them. Let's start with what scrubber water is, or scrubber effluent, what we want to call it. It comes from scrubbing the ship engine from exhaust air when it's using heavy fuel oil. But it's not just dirty water, it's also very toxic because it's contaminated with polycyclic aromatic compounds, metals, extra nutrients that we don't need in the sea, acids and soot particles. What we want to stress is the polycyclic aromatic compounds that comes from the fuel and also the combustion process, even though it's very little of them in the scrubber effluents, but it's also very toxic. It's extremely toxic compared to other stuff in the scrubber effluent. And now this is a graphical abstract of how it looks like under the sea. Or the biological mechanism that we don't often see when we are out in the sea. So it's very much like all living things. You need to have reproduction, and then the larvae that are hatched needs to have time to grow, have things to eat, and then eventually settle down and grow up to repeat the cycle. And at least at one stage of all marine life that depends on the open sea, the pelagic zone, exactly where maritime activity happens. They need to be around here because there's more food to eat, because there's more planktons. It's also this stage they are extremely sensitive to marine pollution or changes in the environment. And if we zoom out, this is how it looks like in reality, that all marine lives are depending on each other and tightly linked together in this network of life. When one link is shifted, the entire system will have cascading effect and not be able to sustain itself. Today we're here to emphasize that the biological response under the sea that is affected by scrubber effluent. And this is how all the biological processes that are needed in order for ecosystem to function. Of course, there will always be fertilization, embryonic development, sperm and egg health, and then the animals need to be able to survive and grow for reproduction and serving their ecosystem duty. Even though the fertilization, the embryonic development, and the sperm and egg health, they are so tiny processes, but they are actually a big driver for the ecosystem function, because without that part, the entire system would not work. I would like to start with telling you what we see when we do research, what happened to animals when they're exposed to scrubber effluents. Here's a copepod, a zooplankton species that many fish species rely on for food. Their reproduction go down very quickly when exposed to scrubber water. And same for blue mussel, our very popular seafood, is also experiencing fertilization reduction when there's scrubber water contaminating the seawater. And there's our study on green sea urchin that we did 2 years ago, that they also showing the same pattern with the reduce in fertilization success when there's scrubber water, when the concentration is going up. And we also had the chance to observe that actually the same effect from oil contaminants coming from cooling water that is running diesel oil, the effect on sea lettuce. This is an edible species of seaweed. Even though it looks like when they're exposed, they remain green in color, that looks much healthier, but it's actually not true because that was during their reproductive season, and the normal treatment, they already reproduce and release spore, and that's why they turn transparent. So the exposed seaweed are not able to do that. And here's a life cycle of copepod. After fertilizations, all marine creatures would need to be able to go through developmental stages in order to get older or serving their ecological purpose. For copepod, it's very long. They have all these stages. They need to be able to mold and change shape and metamorphosize. When exposed to scrubber effluent, it doesn't matter closed loop or open loop, they all has this difficulty in molting, changing their shape from like growing bigger. And this is not just in 2 species of copepod, this would have cascaded effect onto higher up in the food chain because every life stage, they serve as food for fish from different age and different mouth size. And this is a research done in Iceland on cod larvae that they depends on all the stages of copepod in order to grow. So when it comes to copepod development, the few contaminants apparently is really bad for their chitin metabolism, and that's what makes up their exoskeleton. That's how exoskeleton look like when animals shed their skin. It's made of chitin. It's bad by downregulating it and making it not able to happen. And this means that the same effect would happen to all marine life that has exoskeleton metabolism, such as shrimps and lobster, which we very much love to eat. And then 2 years ago, we also observed the same thing in green sea urchin. When exposed to scrubber effluent, they are becoming completely different from the normal sea urchin, which are in clean water. That's how they would look like from after fertilization. They would start to have cell division, and then 2 days old, they start to form their organs, and then 4 days old, they start to have arms in order to start feeding on zooplankton and phytoplankton. And then when exposed to scrubber effluent, they have no really bad cell division and unable to form organ, unable to form skeleton, as you can see, completely different from those. And also, eventually, those that manage to form some skeleton, they have very uneven arm. So they would have hard time guiding the food, approaching the food, because their arm is for them to swim and move, actually. They're not just floating in water, they need it for feeding. And then, actually, other researchers that expose did the similar study on oil contaminant impact on marine sea urchins see the exact same pattern. So we know we're not dreaming. When it comes to mussels, it's the same thing. The number of abnormal larvae go up when exposed to scrubber effluents. As you can see, the normal one, they look like this crystal clear D-shaped larvae, very perfect. And then when they're exposed to scrubber effluent, they start to have abnormal growth of tissue that is too fast. That is no longer D shape, it's all kinds of weird shapes. So the effect was either measured as number of abnormal larvae going up or number of normal larvae going down, and everybody see the same pattern in the scientific community, regardless of the species of mussels. Earlier this year, we had the chance to work with Nofima, which are leading expert in aquaculture of cod. So we learned about egg and sperm health and also larval development as well as fertilization of cod. Together with Eva Lotta and Mia, we did this study exposing cod larvae to scrubber effluent. We didn't even use a lot of scrubber water, maximum 1% that Mia will tell you about more later. We follow the eggs from embryo development to hatching, and that's how they look like. It was there's no way they can survive because they wouldn't be able to eat with the mouth like that and the spine like that. They wouldn't be able to swim. Other study that try to understand the mechanism behind oil contaminants on fish larvae found that when exposed to fuel oil or the polycyclic aromatic compound, cod larvae start to become very different from normal larvae. The gray lines are what's indicating normal larvae standard, how they should be. But then when they're exposed, they become much skinnier, as you can see, and they also have hard time using the nutrient from the egg yolk, so they are hatching with much bigger egg yolk. This is because they can't metabolize the oil from the yolk sac. On top of that, if that's not enough, they're also born with much smaller eye and much more deformed jaw from the standard. The jaw are much more different, as you can see in the photo. So they will have hard time finding food and eating food. To recap all this, here's with the scrubber effluent or other maritime stressor on the marine life, there would be much less reproduction, much less pelagic larvae fulfilling the ecosystem duty, and also much less settlement and growth and survival to maturity. As we know from our research that fertilization, embryonic development, and sperm and egg health are very important for the ecosystem to function, it is really bad to have all this stressor in the sea. And here's a real case for the Baltic cod in the Baltic Sea that I have mapped out that Mia will tell you more about.
Yes. So what you see here is a map showing the shipping routes, one of the most trafficked, heavily trafficked regions in the world, the Öresund. And you also see the reproductive grounds and where cod, and where they then grow up. You know, they are dependent on the coastal areas for growing up. The shallow areas, and then they reproduce in the deeper areas. So when these larvae of cod need to go and grow up from the blue areas to the green areas, they will have to cross the shipping lanes. This is a big problem. So what we see here is that Kerry has written banning territorial waters will not be enough. Probably, maybe not even the actions taken that you are suggesting might not be enough for just focusing on the protected areas for the cod. So I would just briefly show you some pictures of what we are doing now. We are focusing on cod because very little is known about commercially important fish and the impacts of scrubber water on commercially important species. And of course we have a goal conflict here between two really important industries. So we went right into the the, what do you call it, hornet's nest, combining these issues. And what we're doing now is working together with Eva-Lotta, who is a underwater noise expert, to look at combined effects of scrubber water and underwater noise on the development of early stages of cod. So that is related to the picture you saw just recently, that we have this conflict between different things we like, shipping and fish. So this is what the larvae look like in the egg after a few days when it's been fertilized. And here you see we have exposed these little creatures to seawater, scrubber effluent, very low concentration, a higher concentration of scrubber effluent, no noise, intermittent noise, and continuous noise. And it looks a bit messy, and that's how science is. Here is some extremely preliminary results. So you are specially chosen for seeing these things. Here you see, you remember the picture of, this is probably what a normal larvae would look like. So some of the larvae will do okay, or the fish, yeah, up there you see the picture with the normal, what the cod larvae should look like. And this is what we see with only 0.001% scrubber effluent. So they have problems with development of the spine, of the eye, and of the head. And this is with continuous noise and only seawater. Here we have really strange effects with a very, very slim or thin body and a very big head. So that is what they are supposed to look like. And this is what they look like. And I mean, this becomes a freak show when you start looking into what happens when you mix these. And this is what they're exposed to, right? And that's only two combinations of what Ida-Maja just showed you that environmental life is experiencing. So here, I mean, this is not okay. This will never be a big cod. So, in conclusion, I say that we are doing all these experiments, but we know enough now to say that scrubber effluents are toxic to marine life, and they affect early life stages at very low concentrations. So trying to find a concentration that is so low that it's not affecting, I don't think that's a very good way to go. It's better to go towards the origin of the problem, maybe the heavy fuel oil. When early life stages are affected, we know that populations and ecosystems are likely affected. And we have possible conflicts between industries affecting recovery of natural fish stocks. You know, we have a problem with the cod in the Baltic. And even when we do restrictions in the fishing, we don't see the recovery that we're expecting. Maybe this could be one of the reasons. Yes, not suitable, not sustainable. Territorial ban is not sufficient. We already talked about that. And we feel as scientists that we get stuck in the details. And combined effects are largely unexplored. So that is really where we should go. And I think that Ida-Maja also agrees on that we need to look at issues, and everyone else working in this field, that we need to look at pressures at the same time. And some things we already know enough about that we don't need more research. We should just decide and stop. So, lots of people involved in this research. So, welcome to Kristineberg. I will also say that's where I'm from, Kristineberg Marine Research Station. You can find all these nice people and interesting collaborations in science. Thank you.
Thank you. Thank you very much, and thank you also for being here, even though you're on your way to somewhere else today. So, do we have any? And thank you for a very interesting presentation. Do we have any questions?
No one dares to ask anything now after this horror show. Yes, Elle. Meanwhile, I will want to say that I think that there are no bad people here. I think we want to work in the same direction. I just think it's sometimes that we don't know enough about each other's areas, and so this type of forum is really important.
Thank you for a very nice and interesting presentation. And I'm in specific interested of the combination of noise, underwater noise, and scrubber effluents. And have you also been thinking on combining intermittent noise and continuing noise, because it also is a situation in the ocean?
Yes, actually we did. Eva-Lotta is the expert. She can tell you all about the hertz and stuff that I don't know anything about. So yeah, we did intermittent noise and continuous noise and no noise. So yeah, it just gets worse, you know.
Okay, we had one other question over there. Claes, I think you wanted to ask a question.
Thank you very much. It's so interesting to see how this develops, and I think it looks terrible when you look at this, the freak show as you showed. And I just have a question, how big is the concentration out there now in these areas? Have you measured that?
So this is something that Ida-Maja was touching upon. It's very difficult to measure real concentrations of scrubber water in shipping lanes. People are doing that, but because it's also diluted quite quickly, and the machines measuring them are not sensitive enough, as sensitive as the biology. So the biology is more sensitive than the machines, and this is an issue. So we cannot actually measure those concentrations in those really low exposures because machines are not competent enough to do that. There are modeling studies from one big research project, EU project called Emerge, where the concentrations of scrubber water was modeled today and in the future, depending on what actions you take in relation to the RCP, carbon dioxide decisions. So this information is out there, and the result from that is that we are actually reaching those concentrations that are toxic to organisms. And many times I should also say that it can be very difficult to look at all these graphs because you have different concentrations and you have different animals and everything is varying. But the thing is that in many of the experiments you see effects at the first concentration you measure. So the first, you have a dilution series, so at the lowest concentration, and then you actually don't know between 0 and the lowest concentration where is actually the limit where there is no effect. So this information is rarely there, and that is the challenge for people working, for example, with risk assessment like Erik and Anna Lunde. That you get really, it's difficult to give advice. But as a biologist, we know how this works. So the regulation is there to make us get stuck in the details, in a way. That's my feeling.
Okay. Do we have any further questions? And I would like to say a big thank you.
Thank you.
Both of you. Kan du ge den till Erik? And we will now do something completely different and scary and hopefully working. And that is to actually move this lady here up to the corner and to give the control to Anna Lunde Hermansson, who holds a PhD in maritime environmental science from Chalmers, where your research focused on marine environmental effects of emissions from shipping, particularly from scrubbers. During the past 6 months, you've been working on a project investigating disinfection byproducts in ballast water, and that will be presented. And you are not in Sweden, you are in Germany, as a postdoc. So welcome and hope this works.
Thank you. I hope so too. First of all, can you hear me?
Yes.
Good. Okay. And do you see me, or is it
Yes.
the screen you see?
I see you.
Nice. So for those of you who have seen my presentations before, I kind of like animations. So let's see how this goes. But I will try, and otherwise maybe someone on scene can help me. Slides. All right. So I will talk to you about this risk study we did last 6 months in cooperation with AlphaVal about the disinfection byproducts from ballast water management systems on ships. So, as most of you know, shipping is a vector for the spreading of invasive species. And in terms of ballast water, it's when you unload cargo, you put ballast water in the tanks. There also follows organisms and pathogens that could be potentially harmful and invasive. The ship moves to another port and then will discharge the ballast water while loading cargo, and that is when you have this move of harmful species. So the IMO has implemented this ballast water management convention or code to prevent the spreading of invasive species and harmful pathogens. So essentially what that does is that it's creating a management system that either stops organisms and pathogens from coming into the ballast water tanks, or they are actually killed in the tank, so they will not spread. What happens during these management steps is that disinfectant byproducts are also formed, and these are different types of substances that I will talk a bit more about, obviously. But anyways, these disinfectant byproducts are formed in the tanks, and then instead of discharging invasive species or potentially invasive species, the ships discharges these disinfectant byproducts. So then we have a potentially new problem then. We prevent the spreading of invasive species and harmful pathogens, but we might have created a new pressure. So this is just a very simple schematics of how the ballast water management system works. Like you first have a filter step, then a disinfection step, you have your holding time in the tank, and then discharge the water. Sometimes you also have a neutralization step where you remove reactive species reactive compounds in the ballast water before discharging. And you can have additional steps of disinfection and filter before deballasting. So why does these disinfectant byproducts form? This is during the disinfection step, as you can hear from the name. And the most common 3 treatment systems are the UV radiation, chemical injection, and in situ electrochlorination. So UV radiation does not require an addition of active substances, but the energy from the UV will result in formation of radicals and reactive compounds in the water. And then you have the EC and the CI systems, where the system is built so that you add or produce an active, so-called active substance. That can be hypochloric acid or hypobromous acid, and these are highly reactive substances. And treating the water with these different treatment systems efficiently kills smaller organisms and pathogens. But all of these reactive substances also result in the formation of these disinfectant byproducts, or DBPs. So DBPs are many different substances. We often talk about halogenated, so you have like a bromine or chlorine attached to an organic compound. And there are several hundreds of these DBPs known, and they have different properties, different environmental fate, and effects followed by that. So we will not go through all of these substances, but I will just give you 3 examples here where we have 3. I don't know if you see my cursor. Maybe I can. Am I challenging this now? Hopefully you do.
We see your cursor.
So we here have bromoform, which is an example of a 3-halomethane. And it's a volatile compound. It's less soluble in water and therefore could have a shorter residence time in the water. We also have haloacetic acids, here exemplified by dibromoacetic acid. This is a polar compound and it's more water soluble and also contribute to acidification. And then finally, we have a substance down here, which is a dibromoacetonitrile, which has this nitrogen functional group attached to it as well. So these different substances and substance groups have different toxicities. So in general, for these 3, we say that haloacetic nitriles are more toxic than acetic acids, are more toxic than 3-halomethanes. But this can vary between different substances. So the aims and objectives of this study was to see if we could detect differences in the DBP formation based on the different ballast water management systems. So we have the 3 most common disinfection methods, UV, EC, and CI. And then we also wanted to investigate the filter versus no filter step. So if we have filtration before the disinfection, is that affecting the formation of DBPs? We also wanted to look into and estimate the cumulative environmental risk in realistic port area scenarios, and then by that identify knowledge gaps and possible measures for the future. So in terms of methodology, this project was a lot about data collection. So what we did was that we collected and compiled a lot of data on DBP formation from different systems, from land-based data or land-based facilities, and that is then done within the IMO approval process for these different systems. So that was, today I think it's 100 systems that are approved. And from that we found 60 disinfectant byproducts that was detected in more than one sample. And then we also have some limited data, but still some data on ship-based monitoring. So we have 3 onboard monitoring campaigns that has been conducted by Australia and also in collaboration with Denmark. And then we also found the US EPA database on vessel general permits. So this is where ships report several different things about their vessel that arrives into US waters. And that includes if the ship has a ballast water management system and what kind of system that is, and also if they have done chemical monitoring of these DBPs. So for that, we screened over 100,000 documents, and we managed to collect a lot of data from that collection. Finally, in order to do this realistic port scenario data from 2018 from the Helcom data repository, and this is data that is modeled by a ship traffic emission activity model supplied by the Finnish Meteorological Institute. So, some results from the US EPA VGP annual reporting. Sorry about all the abbreviations, but this is the ships that comes into US waters that are self-reporting, basically. So in 2024, we found 8,781 reporting or annual reports. And as you can see here, confirming what we said before, but that UV systems and EC systems are the most common systems, with CI being 5%. What is interesting, if we look into the chemical monitoring and reporting instead, this is for 2023 until 2025 or beginning of 2025, we see that here EC systems are overrepresented. And that is because within the IMO, addition of active substances require more monitoring, and therefore they monitor and submit that data as compared to, for example, UV systems where only 2% have reported chemical monitoring of DBPs. So what we can do with this data is what we wanted to do with AIMS was to compare chemical injection, electrochlorination, and UV systems and the formation of disinfectant byproducts. So here is only two groups of substances, the 3 halomethanes, for some of bromoform, chloroform, bromodichloromethane, and dibromochloromethane. I will not ask you about the names afterwards, but I just want to give you them here. And then we also have the 5 of the haloacetic acids. And you can see the names below here. Anyways, we also wanted to compare the filter and the no filter systems. So that is why each management system is represented with 2 different box plots. I also want to say here that this y-axis is on the log 10 scale. So yes, there's a lot of overlap between the data, but we can actually see a significant difference between the filter and the no filter systems for CI and EC. And what we can also see is that UV systems in general appears to produce lower concentrations of the halogenated DBPs. We can disaggregate the data even further, so we can divide into basic and final. These represents then the land-based monitoring. And then we have the, now I don't think. Yes, so we have the basic and final, filter, no filter. These are land-based, from land-based facilities during the approval process. And then we have the SHIP, so the onboard monitoring, filter, no filter. So these are from the US EPA data and also from the Australian study. So this is only for the THM group. And we have the same for the EC systems, and then for the UV systems, you see. So what we can actually see here is that we have a significant difference between the land-based facility data and the ship onboard ones for UV systems. Just want to say here that the number of studies that actually detected DBPs from UV systems on ships were only 6. So it's largely underrepresented in that sense. Yes, so what we can see from this figure is that land-based testing may not be representative of actual DBP formation, and we can again see a significant difference between the filter and no filter options. So, finally, moving on to the environmental risk assessment. I hope I'm not saying something that someone already had said, but we can determine the risk of a substance entering the marine environment by comparing a predicted or measured concentration in the environment to a predicted no effect concentration of the same substance. And this is called the risk characterization ratio. And if this ratio is above 1, we say we have an unacceptable risk. So first of all, we need to determine the predicted no effect concentrations. So I will just give you a brief recap on what that is. So a predicted no effect concentration is the concentration of the substance below which adverse effects in the environmental sphere of concern are not expected to occur. So this would be like a safe level. We don't like to use that word, but anyways. And these SNEC values are derived from substance-based ecotoxicological testing of single species in the laboratory, in relevant matrix and also with relevant endpoints. So what you do then is that you, in an ideal world, you have a response. This can, for example, be mortality. And then you have, on the x-axis, you have the first is control, so no substance added. And then you have increased dose of the substance that you're testing. So E is the lowest dose and E6 is the highest dose. The lowest observed effect concentration is the concentration tested where you found a statistical significant effect. And the no observed effect concentration is the concentration step below that. So initially, the maximum concentration where you did not find a significant effect. And this NOEC is often used then as a critical value divided by a safety factor, a so-called assessment factor, to derive your connect value that is then used in risk assessment. Moving on, we need to calculate or estimate the predicted environmental concentration. And in this study, we did that by using a so-called MAMPIC model. And this is also used in the risk assessment of ballast water. And this stands for Marine Antifouling Model to calculate predicted environmental concentrations. So we just use MAMPIC. And this is a two-dimensional hydrodynamic and chemical fate model that assumes steady state. And what you need to define in this model is an environment, so in this case, a port, a substance or compound, here represented by bromoform, and then emissions, and this is the mass load per day. So gram bromoform per day emitted in the. So to calculate the emission, we wanted to use realistic data. So we used the ship activity data from STEAM, as I mentioned in the methodology, and plotted that data on a European scale. So all of these bars here represent ballast water discharge volumes. So in Europe, in total, it was 4,300 million tons. And then Rotterdam and the Strait of Gibraltar have like the highest volume loads. We have also zoomed into the Baltic Sea, where we see a sum of 550 million tons. And here's Skagen, Gdynia, Gdansk, and Ust-Luga have the highest volume loads. So for the risk assessment, we choose to model Port of Rotterdam and also Port of Gdynia. These are two very different ports with different water seas and ship traffic. So now we have the volumes, but we also need to know the concentration of DBPs in the ballast water that is discharged. So then we use the onboard data. So the data from the US EPA and also the Australian studies. And we calculate the geometric mean that is indicated by the circle in the middle of these box plots, and also an upper level. So that is the top whisker, basically. I want to say here, due to limited data from the onboard monitoring, we know that we can find around 60 dBPs in ballast water, probably more. But for this risk assessment, we only include the two groups that I showed you before, and this is 9 dBPs represented. So the calculation of the predicted environmental concentration can then move on. So we did that for the environment, 3 different environments, Port of Rotterdam, Port of Gdynia, and the default port that the ballast water working group within GESAMP in the IMO is using. And then we have the compounds, which are these 2 groups, so 4 THMs and 5 HAAs. And then finally, we have our emissions, where we estimate the volumes from steam and then the concentrations from onboard monitoring. Now we can do this substance by substance, but what we want to, and I think many of the presentations has already emphasized, is that we need to look at more than one substance and more than one waste streams at a time. So here we will limit ourselves to ballast water, but we want to include, we don't want to look at to the risk substance by substance, but we want to do a cumulative risk. And we do this by concentration addition concept, where the sum of PEC-PNEC ratios for each different DBP of these 9 DBPs are summarized. And again, if this RCR sum is above 1, we have an unacceptable risk. So some of the results here, I'm just going to show you briefly, is that here we have our 3 port scenarios. the daily discharge volume based on steam, and then the daily loads calculated for each port in the geometric mean scenario to the left, and then the upper whisker, so that's the 95 percentile, to the right. On the three bottom rows, there is the cumulative risk, first for the THM, then for the HAA, and then the summarized of all. So what I just want you to look at first is that we have unacceptable risk in certain scenarios. And again, this is only from 9 dBPs. Then if we compare, for example, Port of Rotterdam and Port of Gdynia, that I mentioned are two very different ports, and as you can see, have very different loads in terms of volumes and also in terms of mass of these disinfectant byproducts. The water exchange and the properties of the port can actually make this less trafficked port, Port of Gdynia, because of its smaller size and less efficient water exchange, you will have a higher risk. But also important to note here is that we have very large volumes and large mass of DBPs in Port of Rotterdam. The risk is not that high, that is true, but that is because that water is ventilated out by, for example, tidal flows. But that water will end up somewhere else. So that's important to include in this assessment. And then finally, we know that chemical fate and toxicity matters. So if you look at the loads of THM, that load is much higher than the daily load of the haloacetic acids, but the risk is usually and often higher for the haloacetic acids. So you can have certain substances can have longer residence times in the water column, for example, and even with lower loads, you will exceed the predicted no effect concentration. So with that, I just want to finally say that we need to include more substances in the environmental risk and impact assessments. We need to create representative environments and emission scenarios when we do these risk assessments. And there's also an urgent need to address cumulative effects. And that's also waste stream by waste stream, but also looking into many different pressures that Mia, Nidamaya, and so on has already mentioned. So with that, I want to say thank you for your attention. I hope you could hear me and see the animations. And thank you for letting me join from abroad.
Thank you very much. Can you hear me?
Yes.
So thank you very much. And it actually worked very well. Not like last time. Do we have any questions to Anna? Short ones, because we're a little... we're a little in time constraint. But do we have any quick questions, or everything is clear and we have some people working with ballast water here? Do you want to add or ask anything? No. Well, thank you very much. And are you going to continue joining, or can we shut down this Zoom? Are you going to stay on?
Yeah, I will stay on until the break or the lunch.
Okay, so it's only one more presentation then. Yeah. But thank you very much. We'll give you an applause.
Thank you.
And time for the last presentation before lunch, and that is, yes, Erik Ytterberg, antifouling and hull cleaning. And now you work at IVL since 1 week. But you have a PhD from Chalmers, environmental science.
From Stockholm University, actually.
Yeah.
But I've been at Chalmers
but you've been at Chalmers for some while.
Yeah.
All the time I've known you.
Yes.
Welcome.
Agreed. Thank you very much. Yes, I am from IVL since 1 week ago. And I will give a presentation about what I've been doing there for the last week. Now, this will be a presentation mainly cover what we've been doing at Chalmers the last decade or two. Yes, thank you. Can't find her. Yeah, so now she's at my computer instead. Okay. No, this doesn't work. Here we are. Okay, so yes, I've been working since almost 20 years now on antifouling paints, so that's a long time, and I'm still active in the field. And the reason for that is basically what you see here on this figure. Since this is data from a report that I borrowed from IMO, each dot here is a specific vessel, and where we have information about the biofouling condition, and also how that translates into increased fuel penalties and greenhouse gas emissions. So the light green part here, this is the light slime, so only small part of algal growth, and then you get more heavy slime, that's the dark green part, and the pinkish part here, these are barnacles and other animals attached on the vessel. So this highlights that it's very important that you have an effective antifouling strategy. And what are most ship owners doing then? Yes, they're using antifouling coatings that contain and release biocides into the environment. And this is a report or an article published a couple of years ago where researchers went through the literature and also from different regulators and found that there were approximately 1,000 different antifouling coatings that exist globally. And roughly 25 biocides or active ingredients were used in the antifouling coatings. 10 biocides roughly is approved to be used on the European market. And we also see that copper's oxide, so inorganic copper, that's the dominating biocides in the antifouling coatings on the market. So roughly 3/4 of those are used. So what does that mean in practice? Well, that means that we also have a lot of emission of copper taking place into our marine environment. This is a study we did for the SWAM agency a couple of years ago, where we compiled the different sources of copper to the marine environment. We saw that rivers is the main contributor, but that's also most of that is natural sources. But when we look at the anthropogenic sources, we see that shipping and leisure boating is the main contributor. And 1/3 approximately is coming from ships and leisure boats coated with antifouling paints. The ratio is roughly 1:10 when it comes to the emission from leisure boats compared to the shipping sector. And as Fredrik also mentioned previously, one of the assignments that they have is to define what is environmental state in order for this Marine Strategy Framework Directive. And this is also something that we have been working together with the SWAM agency to set this threshold value, what the environment can cope with, and then relate what is then the concentration in the environment. And as you can see here, it's red almost everywhere. Here we have a small green part where we actually reach good environmental status, otherwise we fail to do that. So the question is then, what kind of response should environmental regulators have? Well, one response could be to try to reduce the input of copper from antifouling paints, and that is also something that the SWAM agency and other agencies in HELCOM are working on under something called Baltic Sea Action Plan. In order to achieve good environmental status in the Baltic Sea. But what they are targeting then is recreational craft. And the reason for that is something that we heard from Karin as well. You need to go to IMO, etc., etc. That creates a lot of time constraints. But if you target the leisure boat sector, that's more easier. But I wanted to emphasize that this, now we're talking about the shipping contribution and antifouling coats for shipping sector, but this is being discussed at the moment, and we know that shipping is a large contributor of copper to the marine environment. So what are then the alternatives? This is something that we have been working on during the last decade at least, try to assess the efficacy of different antifouling coatings. And you can lump them into 3 different categories. You have the biocidal antifouling coatings with the traditional binder, the ones that I showed you previously. And then you have these silicone foul release coatings. They function a little bit different, that they create these non-stock properties instead. So the organisms have difficulties in it to attach to the surface, and also when you come up to a certain speed, they easily fall off. And these silicone foul release coatings, they can either be biocide free or they can also contain some biocides as well. And the third option here is to have an ice-going hull coatings, typically made of a hard coating, epoxy-based. But then you also need to have in-water hull cleaning regular, because these coatings does not have any anti-fouling properties. Okay, so if we have received a lot of questions of what are then the alternatives, what are the most sustainable that we can use instead of these copper-based coatings. And one criteria in order to give that answer is to look at what kind of potential hazard can the different of these other coatings have for the marine environment. And this is something that Maria Lagerström sitting there and Pei Hu, who is our PhD student, she's been working quite extensively with that, and this is some data that I received a couple of days ago from Pei Hu. So Anna mentioned a little bit about this risk assessment concept. This is how we try to do a product hazard potential assessment. So we basically go through all the safety data sheets of the different products, or Pei Hu is doing that, and then she compared that to a threshold value, and then we can say something about the hazard potential that the coating can have. Large number indicate that it's more hazard, low indicate that it's less hazard. So the first part here, over here, this is the traditional biocide coatings, so the copper-based coatings and other biocides. We see that it's a huge variation, but it's quite high here. And then we have the biocidal foul release coatings. It's also kind of overlapping here. So I wouldn't say that that's a sustainable option compared to that one. And then we had a hard epoxy. This is significantly lower compared to these two. And we have the biocide foul release coating, which is also significantly lower compared to the traditional ones. So in that perspective, when we look at potential hazard, we will recommend these two guys. But then the next question is, okay, we want them to be effective as well, because we don't want to have a fuel penalty of 30-40%. That is not a sustainable option. So we've done a lot of research regarding the efficacy of different coatings, and this is some of that data where we, together with ship owners, assessed the efficacy of a bunch of different products in ports around Europe. So this is the biocide-free inert coating without any anti-fouling properties. We see that we receive a lot of barnacles. Of course, we don't want to have that situation. This is then the business as usual scenario, so the biocidal copper-based coating. We see that they function quite well. And if you compare that then to the foul release coating, this is with biocide. They also function as well or even better compared to the copper-based. And then we have the foul release coating, which is biocide-free. And they also function in similar way as the one with biocide. So in that perspective, we would recommend that we don't really see that you get an extra boost in terms of protection with adding a biocide to the foul release coating. So they seem to be working kind of similar. And so based on these kind of results, we have been working quite extensively. Also, Dinesh is somewhere here. Yeah, he's over here. He's been working together with us as a postdoc previously. And we tried to develop something called Hull Master. So that's a decision support tool for the industry or others in order to compare different hull maintenance scenarios for a single ship and route. And we then consider both the economic part for the ship operator, but also the societal perspective in terms of what could these environmental emissions, both to the atmosphere and to the marine environment, cost for society. So the input is that you define your business as usual scenario. That's typically this copper-based coating, and then you define the alternative scenarios, which could be this foul release coating or inert coating with in-water hull cleaning. And the output will then be the annual average cost difference between the different scenarios, both for the ship operator and also for the society. You are most welcome to download it using this QR code, and then you can play around with this instrument. Otherwise, you can contact any one of us here, the Chalmers team over there and me representing IVL. I don't think I have time to go through this, but we have this fouling growth model that I showed you the data for 1 year. We have been doing this for a long time, so we take picture every month, and then we try to assess what will be the fouling growth in different ports, etc. We also have the biocidal mode, so we have information about the release of copper, for instance, to the marine environment. And finally, we have this tool output, which will be then the operator cost and then also the societal cost. Yes, I just mentioned that. So the fouling growth model, we have the buy-side model, and we also have then the operator costs. So this is data that we received from the industry. And then we have the socio-environmental damage cost. This is something that we obtain from literature, or something that we have been doing in other studies as well. So here is just an example of how this tool could look like, that you can specify your own vessel, or you can use predefined vessels that is already predefined in the tool. And then you can choose the different scenarios, and you compare that to this business as usual scenario, and then you get the cost difference. So the economic part, this is then based on the increased fuel consumption or the decreased fuel consumption. And also the cost differences between applying the coating, for instance. Silicone-based coating are typically a bit more costly than traditional ones. And then you also have the societal costs, and these are then based on health impact. We have climate change impact, marine eutrophication, marine ecotoxicity included in this tool. And together with other colleagues, Lena Granhag, as an example, we try to include endangered alien species in the long run, and microplastic is also something that Peju and Maria is working on. And just want to show you one result from this tool. This is a project that our previously postdoc Yang-Rong Kim worked on, where we then choose 4 different operational profiles. So we have 4 RoPax vessels operating in the Baltic Sea region. We then used 3 different coating types, so the copper-based coat, the inert coat, and this foul release coating, the biocide-free one. And then we set up different hull maintenance scenarios depending on the dry docking interval, and also how frequently you clean the hull. And what we wanted to assess is what is then the most sustainable ship hull maintenance strategy in the Baltic Sea region. This basically shows you a little bit more about the different scenarios, but I'm not going to go into too much detail about. But it's a lot about the in-water hull cleaning frequency. And I just want to emphasize that for the foul release coating scenario, we only have 3 scenarios, because you're not recommended by the paint producers to clean on the foul release coatings. So these are then the results. A lot of information over here, but I want you to pay attention to this top right corner here. This is where you have the most environmental savings, and the savings for the ship operating compared to this baseline scenario which you have here. So anything that goes up here indicates that that's the most sustainable option for the 4 different vessel and the routes. So you see the green dots, they are dominating in all of these scenarios, indicating that that's the most sustainable part, both in terms of the economic for the ship operators and also for the environmental savings. And we came up to this conclusion in this paper, that the saving for the ship operators during a 10-year period could be up to 9.3 million, and the socio-environmental damage saving could be up to almost 8 million compared to this baseline, which is then a copper-based coating. So, to conclude, I highlighted that copper-based antifouling coatings are one of the largest anthropogenic sources to the Baltic Sea. We do not fulfill good environmental status, and shipping can quite easily, I would say, not all ships, I would say that, but in general, we see that biocide foul release coating is a sustainable option. And I can also emphasize that this tool is currently only available for the Baltic Sea scale, but we will update it and have it ready for all European waters. And with that, I also want to thank you, the financiers, which is primarily Lighthouse and Trafikverket, but also SWAM, I forgot you, sorry, and then with help from the team at Chalmers. Thank you.
Thank you. And this was funded as an innovation project, the second one. So we actually got something that we could use. Not all projects end up with a useful tool, but this one certainly did. Do we have any questions to Erik?
Or do you want to eat?
Pardon?
Or do you want to eat?
Yeah, or do you want to eat? Okay, so
Yeah, I think Frederick. Yeah.
Yes, I see him, but I only
Sorry.
need a microphone.
Thank you, Erik, for a nice presentation. I was thinking one of your first slides when you compared the risk between the various paints. I was a bit surprised that the hard paints or epoxy paints had quite high risk. Can you go back to that and elaborate a bit why is that? Because is the in-water cleaning included in that or not? Yes, that one.
No, it's not included, but I forgot to mention, it's in a log scale, so if I would have it in a normal scale, you would just see it down here, I would say. But it is some variation here that it almost go up to, I think, 50 or something, or almost down to 1. I don't know if Peyu, if you want to jump in and say if you have some products that are up here, what can be the driver of that?
I'm trying to think now.
It's on.
Okay. Yeah, as Eric mentioned, it's in log scale, so the actual value is not that high.
But that is something we will go into detail about the different categories and look at the variation and see what is then, what is driving the overall potential hazard, and this can also be some recommendation also for the industry that skip this substance and you can reduce.
Oh yeah, now that I remember, sorry for that. The toxicity of the epoxy coating mainly comes from the binder, which is bisphenol A. But there are products using that, which if you go to ICA, you can find the PNEC value for the binder. But for other coatings, you don't have that kind of data. So we try to collect all the information that are available, but unfortunately there are binders that you just don't know what it is and the toxicity of it. That's why you have some that are like 50, some like 0 point something or even 1. Yeah.
Thank you.
Thank you. So there are 2 questions here.
I just want to fill in that it also depends on what you had before on the hull. I mean, if you have to take away a lot of scrappy paints or crappy paints, then I guess this will rise a bit. So.
You mean in this perspective? You mean?
Yeah, right.
Yeah.
Because applying hard epoxy is a process. For those who have done it, we know that it's not so easy. Okay, thanks.
And Alan, you will get the final question. Or maybe no.
Thank you, Eric, and a very interesting presentation. And I'm happy to see also that now you launch a solution for all European waters. And I would like to add to that. Do you know how it looks like worldwide to have similar strategy services for planning for antifouling strategies? Thank you.
Yeah, that's a good. I mean, one of our ambition. Firstly, it was to look at the Baltic Sea, then to expand it to on European level. Now we have Yang Rong Kim, who was formerly a postdoc. He's moved to Singapore, so it seems for us very interesting to look at on an Asian perspective. So yeah, depending on the funding that we can gather, but we would be very interested to make this more like a global concept, the whole model. Yeah, thank you.
Thank you. The last question.
Okay. Yes, again. I just wanted to ask you, do you mean that you are looking at leachates from these and testing them, or looking at individual compounds and the toxicity of them when you make the risk?
Thank you for your question. So we are only looking at the paint product based on the information provided in the safety data sheet. And for this calculation, we also exclude the solvents because we only want to look at the environmental risk. So when you apply the coating, solvent would evaporate, or there are some chemicals that are also evaporate, like inhibitors. So we also included that. So these are just the potential risk of a dry coating product. Yeah, they might not leach.
But maybe we can add that, Peyu, that you're doing, we're trying to estimate the environmental release to the environment, and in the end also be able to do a proper risk assessment.
Yes.
So predict environmental concentration based on that. But that would be impossible if you want to address 1,000 paints. Then we can come back in, I don't know, a couple of 100 years and give you the results. So this is a simplified version in order to compare the different paint categories.
Okay.
I just want to add then that it will be very difficult to know what the toxicity is in real life if you don't test it on organisms that live.
And that is something that we're doing as well. Yeah. So we are producing paint leach as well and test that and provoke a response towards different organisms, both for all of these classes. So we try to take the different perspective, but as I mentioned, also doing that and kill a lot of animals by producing 1,000 leachate water, that will not be feasible either. But
I understand. Yeah. We have our.
Thank you. Now we need to. Very interesting topic, very interesting discussions. But you're going to Vienna, and we are going to lunch. So thank you very much.
Thank you.
So lunch is served outside, and please be seated at 1:35.